In this video, we're going to work on the labs of the function. So as we introduced in the lecture part, what is a function was basically a function has a collection of instructions and data to perform a certain tasks. We try to make the functions as most efficient. So therefore, try to encapsulate all the needed information and instructions and data together. And a function will be one of the most basic levels of reusing code in Python. So it has lots of benefits. Why we use function? It's easier to maintain, so we can reuse the code. It's easier to debug, and we can plan the whole logic of the problems, and we can do divide and conquer. So it's definitely highly encouraged that you implement your functions in a more efficient ways, and especially make your function a smaller and make it autonomic. One function just do one thing. That will be the best. So let's take a look. How do we do the functions? We first need to define a function. To define a function, we will have to understand the syntax. To do that, the first thing is we're going to have the def as a keyword, and then has the name of the function, and then arguments 1 and 2 and so on. It depends on your function. You may need some 0 arguments, you may need 5 or 10, right? So normally it's doesn't need that much. Normally it's just 1 or 2 or 3. If you need more, then it's better just to pass an object to the function. And once you have the function, the arguments, this will becomes the parameter will be able to access inside the whole body of the function. So inside here, and once it's returned, if do all your stuff right here. Once you finish the job, if you want to return a desired results, then you type the keyword return, and then it will actually return the value back to the function. So that's the basic definition, basic things. So I'm gonna first erase all the output, and then we starting from beginning. So what this says, a simple example of function definition. So in this one, we just perform a atomic task of a function. We just print out hello as the say hello function. So you see I have a definition, def as keyword, and then I have the parentheses for parameters. In this case, I don't need any parameters. And then I have this column to indicate that's the header, end of the header. And then I am going to type the body of the function. And so how do we call a function? Simply just type the whole word, and then put a parenthesis. What it does this is you tell the program, okay, I'm going to call the function now, and then I will go into the function, I will execute this line, and then it will print out the results, and we don't have any return value, so that'll be it. So let's run this one. So now our function is defined. Now I'm going to this line, I'm going to run it again. What we're going to expect is actually print out a hello. So the hello is right here. See, here we don't have any print. Everything happened in here because we define the function. We tell the function tells the computer just to go ahead and print hello. And then sometimes you forgot the parenthesis. That will make an error. So if you miss the parenthesis, then it will say, oh, okay, this is just a say hello, display the fact that hello is a function. It did not call the function at all. So keep in mind, sometimes you want to accept the parameters, or so the parameters will be defined when you define a function. Those are called parameters, but when you call the function, those becomes arguments. So the whole process is actually from arguments to the parameter. So from arguments to the parameter. So the name actually will be assigned with a value Jose. So this will actually start to print out the hello Jose, right? This will start print out hello Jose. So this definition is defined greeting, and then we are calling this function. You see, we are actually has this 9. And some of you may curious why we have this one, why we has f right here. That means we are actually format a string. We are format a string. So this name is actually taken from there. What if we take out the f? What if we take out the f? So if you run this again and then you call this, it's just to give you the name. So you basically tells the string, okay, we format the string and make this as a actual parameter. We're going to take the parameters value. If the parameters value is whatever, then we're going to print it, the value of the parameter. And use the return. So if we have a return value, then we can directly return the final calculation back to the function, and therefore whoever is calling this function is going to receive that return value. For example, we have a definition of this function, and then we are going to call this function. It's going to print out the two values. The addition, that will be 9. So I can actually assign the 9 to the results. So right now the results is actually 9. I can print it out. It's 9. Okay. Then what happens if we put two strings together? Keep in mind, what's the plus sign mean for a string? That's actually concatenating, right? That's actually concatenating. So it's going to concatenate the two strings together. So some very common questions is, what is the difference between the return and the print? The print actually is just to print the results, while the return would not print at all. The print is just to show the value on the screen. However, it did not give the caller of the function a value. So this basically returns nothing, while this one returns the summation of A and B. So suppose we're just printing this. We print it out. However, there's no arrow. There is an arrow. So print result. It says print result is not defined because I need to run it first, right? I need to run it first, and then I print it out. You will see it's actually printed out. It's printed out. However, if I assign a value to this print result, you would not receive anything. And this one is actually return the value. You would not see any output. But if you are running inside a Python script, because we're using interactive environment, so you happen to see that. But if here, if you put another 9, you see, okay, I'm gonna have A is print underscore result 10 5, and I want to see the value of A. I want to check the value of A. You're gonna see the A, let's do this one. So you see the printout right there. However, if I am checking, check the value of A, it's just print A. It's gonna be, take a look, it's gonna be none. However, here you see this this is showing the results as 15. However, I am going to show you A or B is actually return result 10 and 5, and so here you're gonna see nothing. And then one more line, we print out check the value of B. So we print B, you're gonna see 15 now. So here is execute, we don't see anything, but when we check this, you're gonna see 15. So okay, that's the difference. So if you don't return anything, the return value will be none. Okay. But what happens if we actually want to save the results for later use? Oh, that's exactly what happened, right? It's right here, my results. So that's exactly what we are doing here. Okay, another example, adding logic to internal function operations. So sometimes we want to we want to add logic to the internal functions. For example, if I am checking the even number, I actually can add some logics inside the body of the function, and then I return the results. So in this case, we're actually checking if a number is an even number. So we can use the modulus to check if they're equal, then this is going to return a true or false. If it's even, it's going to return true. If it's an odd number, it's going to return false. So let's define this. And 20 is going to be true, and 21 will be false. And check if any number is in a list is even. Suppose we have a list, we pass the list, and then we're going to has a for loop. So a number in a number list, and for every single number, we're going to check if it is a even number, we return true. Otherwise, we pass, right? We pass. So in that case, we're going to only what will happen? What will happen is we are actually just returning a true values. Return a true value. So this, what it does is you're going to check the whole list, and you are going to, this will terminate the function. It says, okay, I find a list of one even number in the list. Okay, so that will be the definition. So what will happen here is just going to give you the true. So in the whole list, you have at least one even number, and for this one, you're not receiving anything. There's no values, right? So it's a very common problem that you only return part of the value. You forgot to return. For other cases, you need to return a false value. So it is very common mistake. So we need to check the logic, make sure you return true for the even number. Otherwise, it's gonna be the false for the odd numbers. So now I'm checking this. I'm redefining this. Now I am going to checking this one. You notice there's something wrong, right? Something wrong, because this is actually for the very first one, you have the odd number, it will return false right away, and it terminates the whole execution. What you can do is you can actually pause that step, or tap something like a continue. You can continue the loop. You don't want to, because if there is the very first one is odd, you want to continue to check the second, the third, and all the rest if there's any even number. So once you go through the whole list, if there is no even number, then you can return a false, right? So that's a logical error. So the correct definition will be right like this one. So now this one is going to give you a true, and this one is going to give you false, because you're supposed to check this one, this one, this one, every single one, until you can draw a conclusion there is no even number in the list, right? And sometimes you need to return all even number in a list. Then you can just return a list. So the return value can be an object. So suppose I receive a list, a number list as a parameter, and then I am going to return a even number. This is going to be an object, and I have a variable as even numbers. This object actually is a list. So I'm going to have a for loop. So for every single number in the list, I'm going to find if this number is an even number. If this part is true, so what I would do is I will append the new number to my even number lists, and then otherwise I will just pass. When we finish the whole list of the number, then we're going to return the even number lists, and we're returning the even number lists. So that's what we will do. So in this case, I pretty much like in this program, it's like we handpick all the even numbers and put into a even number list and return it. So this supposed to give us all the even numbers. So you see 2, 4, 6, and this one's supposed to give us nothing, right? It's going to be empty list. Returning tuples for unpacking. Suppose I have a list. However, inside the list is a mixture of a tuple. It's a mixture of tuple. So what I can do is I'm going to have a for loop for the stock price, and then print out just the item. The item will be a tuple. However, I can actually unpackage the items into stock and price. I can do that way. So I can do this, and then we're gonna see the items, their tuples, and then we can do this. So unpackaging, and then we can do this unpackaging, right? Similarly, functions often returns tuples to easily return multiple results for later use. So we have a tuple like this. We can have work hours, like the name and hours, name and hours, name and hours. So what we can do is we can simply just do a employee check how many hours they are performing, right? We have a work hours, which is a list, and then we can find the current max and employee of the month. We're gonna check which employees works the most hours, right? So we're gonna decouple. We're going to unpackage the tuples inside the list, and then we find the hours. If the hours is greater than the current, then we're going to update the current max, and we save the employee of the month as well. And then at the end, then we're going to eventually find which employee and what's the hours they work. So that's actually returned a tuple. So that's the definition. Now let's call this, it's find Casey is 800 hours. That's the employee of the month. Sometimes we want to do the interactions between functions. For example, I have example as a list 1, 2, 3, 4, 5. Suppose I want to do shuffle, no shuffle in this place. So we have a list. Then I import the shuffle, and then I am shuffling, and then I am gonna see what's my example. It's kind of randomized the list. Now let's create our simple game. So now I have a list. My list is like this. Then we shuffle it. We shuffle my list. Now the my list is supposed to be like a random, right? So my list is gonna be in this case still has the original one. Now I'm going to reshuffle it. So it's going to be a different one. So the players, it's going to guess 1, 2, 3, the location, pick a number 0, 1, 2, and then you're going to find where is this 0 is at. And so we're going to do this, play the guess. So we will check. So you're going to enter 0, 1, 2. It's a random number, so you have 33% chance to win, right? So I'm just take a random number. I'm gonna say 2. So now we're gonna check. We're gonna check the guess. We're gonna check the guess, right? So we're gonna see if it is correct. If it is correct, and then we're going to play this. We're going to find if it's right, or if it is right. So again, I'm going to check number 2. We're wrong. Actually, it's 0, right? So that's how it works. And then that's about the lab part. The next part is actually assignments. We actually starting to do the assignments as in the textbook. Assignments. Okay. So for example, number 2 or exercises. I should probably call it exercises, right? Exercises. So for problem number 2, a digital root of a number n is obtained as follows. So we basically add up the digits n to get the new number, add up the digits of that to get another new number. Keep doing this until you get a number that is only 1 digit. This number is the digital root. So for example, if n is 45893, we add up the digits to get 4 plus 5 plus 9 plus all of those together, that's 29. And then we add up the digits of 29 to get 11. Then we add up the digits 11 to get 2. Since 2 has only 1 digit, so 2 is our digits root. So write a function that returns the digits root of an integer. So how do we do this? So what we're going to do is we basically just ask people to add integer. To ask an integer, then we're going to do the digital root. For the digital root, we're going to first check the number of n. If n is greater than 10, then we're going to call add digits. We're going to add digits. So then add digits will actually take that number and then make this as a list. As a list, we first make it a string and then make it as lists of the string, and then that's our L. So we can actually first define a summation of the digits. So we have a for loop, and then for every single elements in that list, then we're going to add the digits together to convert that single digits into an integer. Then we add it here, and then we return it. So that will give us the y. If y is greater than 10, what we're going to do is do this again. We'll add the y again. So that's exactly what we're doing in the logic, in this digit roots. So we can try that, and then let's add just add a big number, right? So, and once I string enter, it's gonna give me 8. So if just to follow that. So there are a few more questions, and you can actually play that. Number 23 is a Sudoku. It's a potentially solved Sudoku problems. It is a pretty interesting one. So suppose I have a Sudoku right here, and we can check it, the Sudoku. So if you want to see it, you can check it. But how do you check it? You're gonna write a function. It's pretty complex problems. And then we also has an implementation of the tic-tac-toe game. So this is just the one implementation, and so you have a chessboard like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you're gonna have all those methods. Feel free to play and execute that. Again, this is not the one that we're showing in the class in the lecture part. In the lecture, we have a different implementation. I'm going to show you in a second. So let me show you that one. That would be this one. So this is the tic-tac-toe. So we define x as x, o as o, empty as empty, then tie as tie. So those are definition of the constant variable as a global variables as well. So we have the display instruction. We print out the instructions here, and then we have the first function as ask yes no, and then we are basically ask the users for yes or no, and then we ask for a number, and then we turn that number to an integer, and then we have the pieces. We have new board, display the board. All of those has defined to reuse the code, and you will notice that our code is relatively simple. So make this complex one simpler. So the main methods right here, we actually doing all those logics. So first display the instruction, and then compute the pieces, and then have a new board and display the board, and later you're going to see we actually display the board again, and then we compute the moves, and we have human move, we have computer move, and then we have the winner, we have the congrats the winner. So it's everything here is trying to just make it reusable, some of the code. Okay, some of the code. So here's actually the execution of the code. You will notice that it is a pretty interesting game. Okay, that's all for this lab.